My goal in this video and the next few is to start giving a sense of the scale of really just the Earth and the solar system. And as we see, as we start getting into like the galaxy and the universe, it just becomes almost impossible to imagine, but we'll at least give our best shot. So I think most of us watching this video know that this right here is Earth. This right here is Earth. And just to get a sense of scale here, I think probably the largest distance that we can somehow relate to is about 100 miles. You can get into a car for an hour, hour and a half, and go about 100 miles. And on the Earth, that would be about this far. It would be a speck that would look something like that. That is 100 miles. And also to get us a bit of scale, let's think about a speed that at least we can kind of comprehend. And that would be maybe the speed of a so let's think of the speed of a bullet. Speed of a bullet. Maybe we can't comprehend it, but I'll say this is the fastest thing that we can maybe kind of comprehend. It goes about, and there are different types of bullets depending on the type of gun and all of that, about 280 meters per second, which is about 1,000 kilometers 1,000 kilometers per hour. And this is also roughly the speed of a jet. So just to give a sense of scale here, the Earth's circumference, so if you were to go around the planet, the Earth's circumference, just like that, is about 40,000 kilometers. It is 40,000 kilometers. 40,000 kilometers. So if you were to travel at the speed of a bullet, or the speed of a jetliner, at 1,000 kilometers an hour, it would take you 40 hours to circumnavigate the Earth. 40 hours to go around the Earth. So it would take you 40 hours. 40 hours to go around the Earth. And I think none of this information is too surprising. You might have taken 12 or 15-hour flights that get you not all the way around the Earth, but get you pretty far, San Francisco to Australia or something like that. So right now, these aren't at scales that are too crazy. Although, even for me, even the Earth itself is a pretty mind-blowingly large object. Now, with that out of the way, let's think about the sun. Because the sun starts to approach something far huger. So this obviously here is the sun. And I think most people appreciate that the sun is larger, that it's much larger than the Earth, and that it's pretty far away from the Earth. But I don't think most people, including myself, fully appreciate how large the sun is or how far it is away from the Earth. So just to give you a sense, the sun is 109 times the circumference of the Earth. So if we do that same thought exercise there, if we said, OK, if I'm traveling at the speed of a bullet or the speed of a jetliner, it would take me 40 hours to go around the Earth. Well, how long would it take to go around the sun? So if you were to get on a jet plane and try to go around the sun, or if you were to somehow ride a bullet and try to go around the sun, do a complete circumnavigation of the sun, it's going to take you 109 times as long as it would have taken you to do the Earth. So it would be 100 times, I could do 109, but just for approximate. It's roughly 100 times the circumference of the Earth. So 109 times 40 is equal to 4,000 hours. And just to get a sense of what 4,000 is, actually, since I have the calculator out, let's do the exact calculation. It's 109 times the circumference of the Earth times 40 hours. That's what it would take to do the circumference of the Earth. So it's 4,360 hours to circumnavigate the sun, going at the speed of a bullet or a jetliner. And so that is 24 hours in the day. That is 181 days. It would take you roughly half a year. It would take half a year to go around the sun at the speed of a jetliner. Let me write this down. Half a year. Half a year. The sun is huge. The sun is huge. Now, that by itself may or may not be. And actually, let me give you a sense of scale here, because I have this other diagram of a sun. this other diagram of a sun. And we'll talk more about the rest of the solar system in the next video. But over here, at this scale, if this sun, at least on my screen, if I were to complete it, would probably be about 20 inches in diameter. The Earth is just this little thing over here, smaller than a raindrop. It's just a small little thing over here. If I were to draw it on this scale, where the sun is even smaller, the Earth would be about that. The Earth would be right about that big. Now, what isn't obvious, because we've all done our science projects in 3rd and 4th grade, or we always see these diagrams of the solar system that look something like this, is that these planets are way further away. Even though these are depicted to scale, they're way further away from the sun than this makes it look. So the the Earth is 150 million kilometers from the sun. So the Earth is, so this distance, if this is the sun right here, if this was the sun right here, you wouldn't even, at this scale, you wouldn't even be able to see the Earth. You wouldn't be able to see the Earth. It wouldn't even be a pixel. But it would be 150 million, 150 million kilometers from the Earth. And this distance right here is called an astronomical unit. And we'll be using that term in the next few videos, just because it's an easier way to think about distance. Sometimes abbreviated AU, astronomical unit. Astronomical unit. And just to give a sense of how far this is, light, which is something that we think is almost infinitely fast, something that looks instantaneous, that takes 8 minutes to travel from the sun to the Earth. If the sun were to disappear, it would take 8 minutes for that light for us to know that it disappeared on Earth. Or another way, just to put it in the sense of this jet airplane, let's get the calculator back out. So we have 100. We're talking about 150, that's 1,000 million. That's 150 million kilometers. So if we're going at 1,000 kilometers an hour, so if we go to 1,000 kilometers an hour, it would take us 150,000 hours at the speed of a bullet or at the speed of a jet plane to get to the sun. And just to put that in perspective, that if we wanted it in days, there's 24 hours per day. So this would be 6,250 days, or if we divide by 365, roughly 17 years. If you were to shoot a bullet straight at the sun, it would take 17 years to get there if it could maintain its velocity somehow. So this would take a bullet or a jet plane 17 years to get to the sun. 17 years. Or another way to visualize it, this sun right over here, it looks on my screen, it has about a 5 or 6 inch diameter. If I were to actually do it as scale, this little dot right here, this little dot which is the Earth, this speck, if I actually wanted to draw this distance at scale, I would have to put this speck about 50 feet away from the sun, 50 or 60 feet away from the sun. If you were to look at the solar system, and obviously there's other things in the solar system, we'll talk more about them in the next video, you wouldn't even notice this speck. This is a little dust thing flying around this sun. And as we go further and further out of this solar system, you're going to see even this distance starts to become ridiculously small. Or another way to think about it, if the sun was about this size, then this speck, then the Earth at this scale, would be about 200 feet away from it. So you can imagine it if you had a football field. So let me draw a football field. These are the end zones, one end zone, another end zone. And if you were to stick something maybe the size of a medicine ball, a little bit bigger than a basketball at one end zone, this little speck would be about 60 yards away, or about roughly 60 meters away. So it's this little speck. You wouldn't even notice it on the scale of a football field, something this size. Anyway, I'm going to leave you there. Hopefully that gives you just starts to blow your mind when you think about just the scale of the sun, the Earth, and how far the Earth is away from the sun. And then we're going to see even those distances, even those scales are super small when you start thinking about the rest of the solar system, and especially when we start going beyond the solar system.